Hello everyone, welcome to the Python tutorial. Here we will try to understand how to use Python to access OGC API features and perform interactive data visualizations. For code implementation, we will be working with Jupyter Notebook IDE, which is already installed and made available to you with the Docker environment. First, we will try to access the notebook file. Followed by that, we will run the code snippets one by one and try to understand the motivation behind the right piece of code that was written. Finally, we will explore the geometries with interactive maps. So let's begin. So to start with the hands-on implementation of Jupyter Notebook, we first ensure that the Docker environment is up and running. So my Docker desktop application is open. And in the terminal, the Docker environment is up and running. And I can also see that I can access the URL for the Jupyter Notebook. So let's click on the URL. And in my default browser, I can see that the Jupyter has opened. And I can also see the notebook that was designed. So I double click on the notebook file to open it. And next, just get rid of all the previous outputs. So I just clear outputs of all cells. Next, we will go through all the code snippets and try to explain the motivation behind the code. So we have divided the Jupyter Notebook into 3 chapters. The first chapter, chapter 1, deals with the imports and the connectivity check. The second chapter deals with the data access. And the third and the final chapter deals with the data visualization with advanced plots and interactive plots. We have used the Folium library along with leaflet base map for the purpose. So let's start with the chapter 1, that is the import part. So we have imported several Python libraries, and the comments contain the exact reason for the imports. So please feel free to go through the comments, try to understand why the import was made. And in the snippet 2, you can see that 1.2 to check the PyGUPI connectivity from the notebook environment. So here we try to establish a connection with the PyGUPI instance running within the PyGUPI container with our Jupyter notebook running in the Jupyter container. So both the containers are running in the Docker environment. In the first installation video, we have discussed in details how the Docker architecture is working. Now, the different thing about this access is that previously from QGIS software and also from the browser, we were using localhost :5000, which was the port number that helped us access the PyGUPI instance. But so this was a port number. If I just highlight it here in the comments, http://localhost :5000. But right now, this Jupyter notebook is running in a Docker environment, and so is the PyGUPI instance. So for that, when two containers are running in a same Docker environment and we want to access the instance from PyGUPI container, we have to follow the Docker networking strategy. So let's run the first and the second code snippet. I just ran the imports to make the successful imports. And yes, the imports were successful. And next, I tried to establish the connection successfully. Yes, the output is PyGUPI container is running. So the chapter 1 has ended. So with this, we can move with the data access tutorial, which is our next chapter. So in the data access chapter, we first start with the 2.1 article, the module number, to list the collections available in the service instance. So here we are trying to check the datasets published with the help of the PyGUPI instance. So if we run the code snippet, the output is the collections, and within that, the ID corresponding to the dataset. So the first dataset is Biosphere Reservoir. The second dataset, if we scroll down, we will get the Biosphere Reservoir Clean. And the third dataset that has been published is the NSG. So the output is in form of a JSON response, and you have to scroll down through the JSON to see all the dataset list of the datasets more specifically that will get published. And in the next code snippet, we are trying to access the landing page of a specific collection. So here we have chosen to proceed with the NSG dataset. So we try to end up in the landing page of the NSG dataset, and all the information that was present in the landing page of NSG that we could see in browser as an HTML representation. Here we can see it in a JSON format. Well, in the browser, there was also a possibility of viewing in JSON format. So the same can be also be achievable with help of Python. So if we click on this run, we will see the landing page information. And next, if you move to the next code snippet, we are just trying to check the queryables present in NSG. Here you can see all the queryable column names with the data types. So it first starts with geometry, then Ken's underscore FFN, then name, category, and followed by the other queryable information. So this goes on. And once we retrieve the queryable information, the next task is to access the items of the NSG feature collection. More specifically, here in this code snippet, we will be trying to access the features of the NSG collection. But you have to understand this code snippet will fetch the first 10 features because in PyGeo API, by default, the paging strategy is set to 10. So if we just run this code snippet, we will get the first 10 features of the NSG collection. And here you can see the first 10 features, the geometries, and followed by this other information. And in the next feature, again, the geometry followed by other information. So if this continues till that first 10 features, in the next code snippet, we are trying to assign the response of a feature request to a variable. So here you can see that in the protected sites, we are trying to access the features and we are trying to store this first 10 features in the protected site features variable. And then in the next line, we are trying to access the first feature from the list of 10. 0 indicates we are trying to access the first feature because since it's stored in an array and the array index starts with 0, so 0 indicates that we are trying to access the first feature. So if we run the code snippet, this is the output. This is our one first feature with all the other variables that's been accessed. And next, we are trying to access the items of the dataset using a customized PyGeo API endpoint. So as we mentioned before that the default paging strategy is set to 10. So right now we are interested to see more geometries, more features from the NSG collection. For the same reason, we are trying to use the capability of the items question mark limit equals to 100. So this particular modification to the URL will help us fetch the first 100 records in the feature collection. In this, the first 100 records of the NSG feature collection. So if we run this code snippet, we will be able to fetch the first 100 features, and then it will be stored in this NSG JSON data. Yes, so this is our output. And next, we are trying to load this first 100 features in a GeoPandas data frame. So if you are not aware of what additional capabilities or advantages we have by loading the data in a GeoPandas data frame, please feel free to go through this comments. You will get a better picture. So here we just loaded the NSG JSON data features, that is the first 100 features that we have extracted into a GeoPandas data frame named NSG underscore data. And if we run this code, we will get the output. So you can see in the output, the columns first starting with geometry, the name, category, and all the other column names followed by that. So GeoPandas data frame has given the output in a more or less tabular format here. So with this, we end the second chapter of the Jupyter Notebook. And next, let's try out our luck with the data visualization with interactive plots. So for data visualizations, we have extensively worked with GeoPandas data frame and the Folium library in Python for creating the interactive base map with help of leaflet. So if we run the first cell in the data visualizations, we will see the geometries being plotted on the leaflet base map. And this is an interactive map, which means we can scroll it right, left, up, down, and we can also zoom it in and zoom it out. Now, in the next code snippet, we are trying to emphasize or focus our search to the municipality of Loru. So there are a specific subset of these geometries which belong to this municipality area. We are using the spatial filter bounding box to narrow our search to the municipality area. And here you can see the bounding box coordinates, which we have searched from the internet. And the BB box stands for the bounding box equals to then the bounding box coordinates. That is the minimum latitude, minimum longitude, maximum latitude, and maximum longitude in this order. And if we just run this, we will get the geometries for municipality of Loru. And let's plot it on the map. You will now be able to get the difference. Right now, the number of geometries are much less. So this is the bounding box, and we are only seeing the geometries for the municipality of Loru. Next, we are just trying to add more clarity to these geometries by adding some buffer zones. So in the QGIS tutorial, we understood the significance of adding the buffer zones and the use cases. We are just trying to reproduce the same thing with help of Python. So if we just run the code snippet, you can see the geometries for the municipality of Loru along with the buffer zones. And if we just expand it, you can get a very clear view of the buffer zones with the geometries. And with this, we end our Jupyter Notebook tutorial. Thanks for watching till the end, and thanks for watching and being with us throughout. Thank you. Goodbye and take care.